Dear student and my friend, Assalamu alaikum. You are watching NPTEL Chemistry E class and I am Chemistry Detective to solve Chemistry class 11th NCERT problem 1.34. Let me make you understand this problem. This problem is based on chemical reaction, and in this chemical reaction our reactant is hydrocarbon gas made up of carbon and hydrogen only, and after combustion, it produces 3.38 grams of carbon dioxide and 0.690 grams of water. Any hydrocarbon on combustion forms only two products, one carbon dioxide and second water. Similar is the case here. This hydrocarbon gas on combustion forms this much of carbon dioxide gas and this much of water. It is also said that volume of 10 liter at STP of this gas is found to weigh 11.6 grams. 10 liters of this hydrocarbon gas at STP weighs 11.6 grams. Now we have to calculate empirical formula of this gas, molar mass of this gas and molecular formula of this gas. This is a numerical problem, and it is based on concepts like empirical formula or like molar mass and like molecular formula. Empirical formula is simplest formula of compound, and it conveys us what is the simplest ratio of mole atoms of various elements present in this compound. Molar mass is one mole of substance, and here substance is gas. Molecular formula is actual formula of compound, and it conveys us information about actual ratio of mole atoms of various elements present in compound. And solution of this numerical problem requires various ideas like for this chemical reaction, or I may say this chemical reaction is bound to obey law of conservation of mass, and as per law of conservation of mass I will use this idea that mass of carbon present in carbon dioxide and mass of hydrogen present in water will be equal to mass of carbon and hydrogen present in acetylene gas, present in this hydrocarbon gas. So first idea is that in accordance to law of conservation of mass, which states that in a reaction mass on reactant side is equal to mass on product side. On this basis I will say that mass of carbon present in this much of carbon dioxide and mass of hydrogen present in this much of water is exactly equal to the mass of carbon and hydrogen present in hydrocarbon gas. So first I will calculate mass of carbon present in this much of carbon dioxide and mass of hydrogen present in 0.690 grams of water, and then I can go for empirical formula evaluation, in which I will first calculate number of mole atoms of carbon and number of mole atoms of hydrogen, and I will make that ratio of mole atoms simple, and I can easily write empirical formula. Next idea is that gases obey Avogadro Principle, and as per Avogadro Principle 1 mole of gas at STP occupies volume of 22.4 liters and has mass equal to its gram molecular molecular mass and contains 6.022 into 10 raised to power 23 molecules. I don't need molecules here, I don't need mass here. I will use the idea that 1 mole of gas at STP will occupy volume of 22.4 liters. Using this idea, I will be able to find molar mass of this gas, and then at last I will find its molecular formula by evaluating common factor and then multiplying its empirical formula by common factor in order to get molecular formula. Now I will practice all these ideas in order to solve this numerical problem. First, I will utilize idea of molar mass of carbon dioxide. Molar mass of carbon dioxide is equal to its gram molecular mass, and it is equal to 44 grams. 44 grams. Molar mass of carbon dioxide is equal to gram molecular mass of carbon dioxide, and it is equal to 44 grams of carbon dioxide. Now 44 grams of carbon dioxide contains 12 gram of carbon. 44 gram carbon dioxide contains 12 gram carbon. 1 gram will contain 1 gram carbon dioxide will contain 12 by 44 gram carbon. Now I will calculate mass of carbon present in 3.38 grams of carbon dioxide will contain 12 divided by 44 multiplied by 3.38, and it comes equal to 0.92 0.921 grams of carbon. Similarly, I will calculate. Similarly, I know molar mass of water is equal to its gram molecular mass, and gram molecular mass of water is 18 grams. Eighteen gram water contains 2 gram hydrogen. 1 gram water will contain 1 gram water will contain 2 by 18 gram hydrogen. Now I will calculate 0.690 gram water contains how much hydrogen, and it comes equal 2 by 18 multiplied by 0.690. It is equal to 0.076 grams. This is the mass of carbon present in hydrocarbon gas, and this is the mass of hydrogen present in hydrocarbon gas. Now I will use these two masses. I will use these masses of carbon and hydrogen in order to determine its empirical formula. I will write elements in same sequence as given in question, first carbon and then hydrogen. Now mass of carbon is 0.921 gram and mass of hydrogen is 0.076. Molar mass of carbon is 12 and molar mass of hydrogen is 1. I will calculate moles. Moles is equal to ratio of given mass and molar mass, and for carbon I will calculate ratio 0.921 divided by 12, and for hydrogen I will do 0.076 divided by 1. It comes equal to 0.076, and 0.921 divided by 12, it also comes equal to 0.076. So number of mole atoms of carbon is 0.076, number of mole atoms of hydrogen are 0.076. Simplest ratio is 1:1. For 1 mole atom of number of mole atoms of carbon 0.076, number of mole atoms of hydrogen 0.076, and simplest ratio between 0.076 and 0.076 is 1:1. So for 1 mole atom of carbon there is 1 mole atom of hydrogen in this hydrocarbon. For 1 mole atom of carbon there is 1 mole atom of hydrogen, or I will say for 1 atom of carbon there is 1 atom of hydrogen. Therefore its empirical formula is, I will write its empirical formula. Its empirical formula is carbon hydrogen in same sequence as in question C1H1, which is equal to CH. And I will here also evaluate empirical formula of mass. I need to calculate, I am interested in calculating mass of this empirical formula, which will be equal to sum of atomic masses of all the atoms in empirical formula. There are only 2 atoms in empirical formula, one of carbon, one of hydrogen. I will add mass of carbon 12 and mass of hydrogen 1, it will come equal to 13. So empirical formula mass of this hydrocarbon is 13. Now I will apply Avogadro principle. Avogadro principle says 1 mole of this gas, 1 mole of hydrocarbon gas has mass, it has mass equal to its molar mass, which is its gram molecular mass. It contains Avogadro number of molecules, any molecules of this gas, and it occupies volume of 22.4 liter at STP. Now I don't need here molar mass, I don't need here number of molecules. I need here to calculate, I need to calculate molar mass of this gas. I will use this relation, that I will be interested in determining the mass of 22.4 liters of gas, because I know mass of 22.4 liters of this gas will be equal to its molar mass, which I have to calculate. Given is that 10 liter of gas has mass equal to 11.6 grams. 1 liter has mass equal to 11.6 divided by 10. Therefore 22.4 liters has mass equal to 11.6 divided by 10 multiplied by 22.4, and it comes equal to 26 approximately, which is its molar mass. Which is its molar mass, because mass of 1 mole of gas is equal to its molar mass, represented by capital M. Now for this hydrocarbon I have molar mass and I have empirical formula mass. I will first calculate common factor. Common factor is represented by N and it is equal to molecular mass, molar mass and empirical formula, ratio of molar mass and empirical formula of mass. Molar mass is equal to 26, empirical formula of mass is 13. So common factor is 2. Now we know molecular formula is equal to common factor, which is 2 into empirical formula. Empirical formula is CH. I have to multiply number of carbon atoms in empirical formula and number of hydrogen atoms in empirical formula by 2. Therefore molecular formula of this compound is C2H2, and C2H2 is nothing but acetylene gas. CH, C, single bond H, triple bond C, single bond H. It is called acetylene. Natural state of acetylene or ethane is gas. It is hydrocarbon made up of only carbon and hydrogen, and information you got is that for welding purposes hydrocarbon gas that is used is acetylene gas. So if you are asked in your exam gas used for welding purpose, hydrocarbon gas used for welding gas is A, B, C, D. Correct option will be acetylene gas. This way we could first determine empirical formula of this hydrocarbon gas, then we could calculate mass of its volume, mass of its 1 mole, I mean molar mass, applying Avogadro principle, and at last I determined its molecular formula C2H2 and identified that it is none other than acetylene gas. Thank you. This is what I have got for you in this short session. Take good care of yourself. See you on day after tomorrow, because tomorrow is reserved for 12th class. Allah Hafiz.